Among the two calculator active FRQs that are given in the practice exam in preparation for the 2017 AP Calculus AB exam, the first one is a problem about tables of values. Now that's interesting because we did something similar last year and the table of values problem was in the non-calculator section. Just like last year, we will use student answers to evaluate the problem and discuss its difficulties. So, it's called a 2016 practice, but it's in preparation for the 2017 exam. We see right away in this FRQ that we have a table of value at the top. T is in minutes, H, which is a height, is in inches. If you don't know precisely what inches are, you don't need to worry about that. When I look at this table of value, the first thing I notice is that the intervals are different. This is an interval of 2, then I have an interval of 3, then 2, and then 3. So if we ever have to calculate an area using trapezoids, we will not be able to use the trapezoidal rule. We will actually have to find the area of each trapezoid separately and add. Another comment I want to make here is that when you have 5 points like here, that makes 4 intervals, right? From 0 to 2, from 2 to 5, from 5 to 7, and from 7 to 10. So let's read the introduction to the question. The depth of water in a tank A in inches is modeled by a differentiable and increasing function h for t between 0 and 10, where t is measured in minutes. Values of h for selected values of t are given in the table above. When I read that, something immediately strikes me, and that is the word increasing. We should, of course, also notice that it is said that h is differentiable, but it seems to me even more special and important to notice that h is increasing, and that means h prime is greater than 0 for all values of t. Will I have to use that at one point in question A, B, C, D? I don't know, but most probably. So we have A, B, C, D, and we will work on question A first. Question A. Use the data in the table to find an approximation for h prime of 6 and show the computations that lead to your answer. Indicate units of measure. This question is probably a confidence builder. By the time we get to the exam, we will have seen that exact question 4, 5, 6, 7 times. So it will really be just pure drill to do it one more time. Notice that it says indicate units of measure. This means that there will be a point out of the 9 points in the FRQ which will be attributed to choosing the correct unit. So we can start talking about that. If h is in inches, t is in minutes, h prime is going to be in inches per minute. All right, so how do we do this exercise? At t equals 6, we are just between 5 and 7, so we can use rise over run. Let's see what the first student did. And the first student always does a perfect job, so we can use them as reference. So rise is 18.5 minus 15.5 over run 7 minus 5, and here we are, 1.5 inches per minute. So the answer is correct, provided the units are correct. There would be no points if you just answer 1.5. There's no partial credit. Let's have a look at student B. They did the same, rise over run, but just like I mentioned, they answer that the answer is 3 over 2. That is not okay because we don't have unit. It's a real pity, so please pay attention to these details. If that was not mentioned, it doesn't mean that they would necessarily give you the point, but if it is mentioned, then for sure you'll lose the point if you forget units. So put units every time. Third student, average value, I don't really know what that third student meant. Usually the third student did worse than the other two, so it's not rare that they don't get credit. And here, same as student A, same as student B, they find the correct numerical answer, but they forget to indicate units of measure. Once again, a real pity, really a point thrown through the window that was easy to earn. 0 point. Question B. Approximate the value of the integral of h of t from 0 to 10 using a right-Riemann sum with the 4 subintervals indicated by the data in the table. And is this approximation greater than or less than the real value? Give a reason for your answer. So we need to use a right-Riemann sum. We have 4 intervals. As I said, we will always use the right side of the interval to determine the height of the rectangle. Student A does this perfectly. Base times height, plus base times height, plus base times height, plus base times height, and he finds 163.5. I'm noticing now the inches here, and this is not the correct unit. Actually, as I was reading the question, I was like, what is the unit of the integral from 0 to 10 of h of t? It's a bit of a bizarre thing, and I don't think the answer is very obvious, but I'm pretty sure it's not inches. So anyway, they don't ask units of measure here, and for a good reason. I think it's just something that is not part of the material of Calc AB. Because h of t is increasing and differentiable for all values of t between 0 and 10, a right-Riemann sum over approximates the real value of the integral. So this is exactly where we used the fact that h is increasing. If a function is increasing, then the rectangles are going to be above the function, and therefore the area under the rectangles is greater than the area under the curve. So the student earned 1 point for actually using a right-Riemann sum, and also 1 point for the correct numerical answer. And finally, justifying that it's an over-approximation earned the 3rd point. All right, student B, here I highlighted some of the work we can see on the solution from student B. This is totally acceptable. You can just write everything you want, but make sure that you give your answer where the B is. You can't just make drawings on the diagram and hope that the readers are going to look up there. So the student finds the correct integral, base times height, 4 times. That's great. And then student B answers, this approximation is an overestimate because h of t is concave down. So let's review what student A said and what student B said to see why student B is wrong. When we have a right Riemann sum, this is what the rectangles look like. And these rectangles, I only drew 2, are going to yield an area that is greater than the area under the curve. But this has nothing to do with the fact that it's concave down. In fact, in the example here, we also have a function that is concave down, and this time the right Riemann sum would be an underestimate. So concavity is irrelevant in this question. The correct answer is that the function is increasing. It's increasing, therefore the rectangles are an overestimate, and here the function would be decreasing, and therefore it would be an underestimate. So 2 points for using a right Riemann sum and for getting the correct answer, but no points for the justification. So the answer to the justification is correct, but the reason is wrong, so it's 0. Student C, that's a nice drawing. I would recommend you to do that every time. It helps you visualize the exercise. It also helps you, going back to question A, when the question was what is h prime of 6, they are asking what is the slope here. And we can see on this sketch that the slope is going to be not too far from the slope of the secant between 5 and 7. So that is why we do rise over run. So the student adds up the areas of the 4 rectangles and gets the correct answer. They don't write any unit, and that's very wise, I would say, because the units are not inches for sure. Approximation is greater than the actual integral because right-hand sum is above the graph h. So the student earned 1 point for using RRAM, 1 point for the answer, but no point for this apparently correct comment that the rectangles are above the graph. Well, the reason is we want to use a term that is more calculus-like. So here we want to say h is increasing, or we want to say h prime is positive for all values of t between 0 and 10. We get the idea, but this is far too much pre-calculus for what the readers expect. Moving on to question C, the depth of water in tank B in inches is modeled by the function g. Now this is really where using a calculator starts to be useful. A and B, we didn't really need a calculator. Question C, we need to remember I have a calculator, I can use it to find integrals at between 2 points. So let's remember to use it. Never attempt to integrate a function, even if it's easy, in a calculator active section. So we have this function g, and it's the same interval and the same units. Find the average depth of the water in tank B over the interval. Is this value greater than or less than the average depth of the water in tank A over the interval? Give a reason for your answer. So the average depth, we're going to do 1 over b minus a, which here is 1 over 10 minus 0, and integrate the function. So here is the answer. That's great, 16.624 inches. This is a correct unit because we are dividing by 10 inches. So really this integral has units inches times minute. It's difficult to really understand what that means, inches times minutes, but when you divide by 10 minutes, you get inches. And whether it is greater or less than the average depth of the water in tank A is going to be answered here by student A. The value is greater than the average depth in tank A because the over approximation of 163.5 inches divided by the time interval is 16.35, which is less than 16.624. And the student says something here that really shows their understanding. 16.35 was an overestimate, or 163.5 was an overestimate, and then we divided by 10 to get the average. So that's an overestimate. So the real value is bound to be 16.35 or less. It is at most 16.35. Now we know that in tank B the average is 16.62, so it's definitely greater than in tank A. In fact, I would find it to be a more interesting question if the situation had been flipped and we had found earlier that it was an underestimate. Now, could we conclude that tank B has a higher average than tank A? We could not conclude that. This would be the exact value, but this would be an underestimate, and therefore the real value in tank A could be 16.35, or it could be 16.55, or it could be 17.9. It could be any number, so we could not determine mathematically that it is lower or larger than this. Back to finding points. There was 1 point for using the correct formula of the average value, and 1 point for getting the right answer using your calculator, and then there was 1 point for a good justification. Student B uses the formula for the average value. This is great. That student just writes g of t. Instead of going through the pain of copying this expression, you can just call it by its name. It's g of t, so I'm going to do 1 over 10 times the integral of g of t dt between 0 and 10. And the student finds 16.624 inches. The average depth of tank A is 16.35, so the student also divides our overestimate by 10, and this is correct too. And the student says the average depth of tank B is greater than tank A. There's no proper justification here, so let's see how the points were distributed. The formula is correct, the answer is correct for tank B, and the conclusion was worth 1 point. This is questionable. It may depend on the year, it may depend on the trend, it may depend on whether the graders overall decide that the question was a bit unclear, but I would really say that this is not a justification. It's just observing two numbers. But that is why I think the question I suggested earlier, that I think would be better, would allow AP to distinguish much better whether between students who understand and students who don't understand the meaning of an overestimate and an underestimate. We can't say here that the student really understood. Anyway, he got the point, or she got the point. Good for them. Student C uses the correct formula, but doesn't get the right answer. Maybe just misusing their calculator, maybe because there's a sign, somehow maybe the student was in degree instead of radians. Make sure you don't make that mistake. But they don't earn the point, and of course they don't earn the reason point because there is no determination of which tank has a higher average. Last question. According to the model given in part C, is the depth of the water in tank B increasing or decreasing at time t equals 6? Give a reason for your answer. Oftentimes, question D is the hardest question. Oftentimes, it is really the one question that is out of the box in an FRQ. You will very often see that questions A, B, C are just like we practice in class, and question D is throwing you off. But this is not the case here, so don't start an FRQ by thinking question D is going to be too hard. It does happen that question D is very manageable. So is the depth of the water in tank B increasing or decreasing? We want to find the value of the derivative at t equals 6, which we do again with the calculator. This is one of the things we are allowed to do with the calculator. And we find g prime of 6 equals 0.887 inches per minute. So since it is a positive number, since g prime of 6 is greater than 0, we conclude that the depth of the water is increasing. 1 point for the calculator part of the question, and 1 point for the answer with justification. Student B, same thing, finds g prime of 6, so they earn the calculator point, but they do not earn a justification point. They say what the answer is, but they don't give a reason. And once again, you want to use calculus in your reason, so you want to say g prime of 6 is positive. That's the reason why we can conclude g is increasing at t equals 6. Lastly, the student here seems to forget that this is a calculator section, and they get into the trouble of using the chain rule, and it doesn't seem that like they're doing too bad. Actually, when I look at it now, it seems like this is great. but you do not have to do that. It's really a mistake to do that, because you're wasting time and you're increasing risks of mistakes. But they did earn a point for looking at what G prime of 6 is. You'll never know when you take the FRQ what is going to earn you a point and what is not. But in this case, it seems like as soon as there was an attempt to find G prime of 6, it showed an awareness that this was what was required, so the student earned the first point. Now the justification is wrong. It's a bit sad because the G prime of 6 is positive here, and the student says G prime of 6 is negative. So maybe it was just a lack of focus and the student meant positive here. Anyway, this is it for the first FRQ in this practice exam in preparation for 2017. I hope you got to learn a few things, and we will move on to all the others in the near future. Thank you.